classing record. Class record. Okay, good. So basically we had already discussed all this. That is variables which we have under regression analysis or under regression, linear regression. We talked about even different types of linear regression, okay? But maybe just to do a recap, we can just go through this introduction before we can now start our practicals, okay? All right. So basically, in statistic modeling, we know that all regression analysis is used to estimate the relationship between two variables, and we can also use the regression analysis or linear regression analysis to do what? To build predictive models. Okay. So under the regression analysis regression analysis model, where for the we took an example of equation of straight line, okay, where we said y is equals to mx plus c, okay. We said we have dependent variable or else it's also known as criterion, that is criterion variable, okay. So this is our dependent variable, okay, and it's the main factor you are trying to understand and predict, okay. So this is the major factor which we are trying to what? To understand or predict. Like for example, in the example of that is rainfall data, okay, rainfall data and umbrella cells, okay, and umbrella cells, okay. We know what that is, we know our objective, okay. That is, we are trying to predict umbrella what cells given different that is trend in terms of rainfall amount, okay. So this is, we are trying to that is to predict the cells or the umbrella cells, okay. All right. So then we also have independent variable, also known as explanatory variable or predictor variables, okay. Predictors or predictor variables and also explanatory variables, okay. So these are the factors which now influence what? Which now influence the dependent variable, okay. They are the factors which influence the that is the dependent variable, okay. Then we have linear regression analysis and helps us to understand how the dependent variables changes when one independent variable or one of the independent variables varies, okay, or vary, and allows to mathematically determine which of these variables really has what? Has an impact, okay. That is, if we are dealing with more than two or more than one independent variables, okay, we can determine which of the variable that is what is affecting our that is um, our output, okay. So technically regression analysis model is based on that is a sum of squares, which is the mathematical way of finding dispersion of what? Of data points. The goal of a model is to get the smallest possible sum of squares, drawn a line that comes closest to the what? To the data. That is, when we are trying to find the line of best fit, okay? The line of best fit. Okay, good. Okay, good. So in statistics, that is, we differentiate between simple and multiple linear regression. And we said for simple linear regression models, that is the relationship, we only have one relationship. Okay, sorry, we only have that is one independent variable. Okay, so for simple linear regression models, the relationship is between the dependent variable and one independent variable. Okay, using a linear function, which is, this is the linear what? This is the linear function. Okay, so if you use two or more explanatory or to predict the dependent variable, then you now start dealing with what? Multiple linear regression. Okay, so for one independent variable, it now becomes what? Simple linear regression. For more than one independent variable, it becomes what? It becomes linear and multiple linear regression. If your dependent variable is modeled as a nonlinear function, because that the relationships do not follow a straight line, then we use nonlinear regression instead. Okay, for this tutorial we'll focus on simple linear regression. Okay, so let's assume this is our illustration or our example which we'll use. Okay, so as an example, let's take cells of that is take cells number of umbrellas. Okay, for the last that is 24 months. Okay, and find out the average monthly rainfall for the same period. Okay, plot this information in a chart, and regression line will demonstrate the relationship between what? The independent variable and dependent variable. Okay, as this thing. Okay, all right. So of course we shall do all this now practically, and we shall also try to what? To explain that is our model, because you can see at the end we'll need a model which looks like this. Okay, like we are predicting the umbrella, that is the umbrella sword. Okay, given an independent variable rainfall. Okay, all right. Now this is where I was coming to. Okay, for us now to perform linear, we have three major methods of performing what? Of performing linear regression. Okay, we have major three methods of performing linear, that is linear regression, or performing, yes, linear regression analysis. Okay, in Excel. The first method is regression using the analysis toolpack. We also have that is using scatter chart and a trend line. In fact, I illustrated this yesterday, but I will still that is show you. And also we add another method. Okay, the other method was linear regression formula. Okay, using linear regression formula. Okay, so I'm going to start with the scatter chart. Okay, then I will come to the that is the regression using that is analysis toolpack, and then we'll finish with this one. Okay, using the formula. Okay, good. I hope now we are ready to start our practicals. Okay, so we'll start with the first method. Okay, using that is a chart, that is a scatter chart. Let me say that. Or let me say using a chart and what? A trend line. Trend line. Okay, so in this case we are going now to plot that is um, cluster. Okay, that is a cluster. Yes, sorry, not cluster, a scatter plot. We are going to use a scatter plot, and then after using now the scatter plot, we will also that is do what? Introduce a what? A regression line. Okay, we'll use a regression line, or we'll plot that is the line of best fit. Okay, and in this case we'll be able to get our model. Okay, we will be able to get our model. Okay, let me start with that. Good, good. So let's start here. So what that is what are we trying to find? That is a scatter plot using the rainfall amount and umbrella cells. Okay, so in this case, what will be our y value? What will be our x value? Someone? What will be our x value and what will be our y value? Yes,
Mm,
Elizabeth?
I think our Y will be the umbrellas sold.
Why? Why is that?
Um, because it's what we will be maybe in prediction.
Yes,
We'll be predicting in future.
that's what we are trying to do, what? To predict. That's what we are trying to predict. Okay? Right. So we will now label this as our y, and this is what? Our x. Meaning here we are going to perform simple linear regression because we only have to we only have one independent variable, that is rainfall amount. Okay, so basically meaning when we plot a graph, okay, that is the umbrella cells should be on our y-axis and rainfall amount should be on our x-axis. Okay, so to do so, we are going to highlight our data set. Okay, only the x and y variable. We are going to only select our x and y variable. Okay, so in that case, then you will go to insert. Okay, we are trying first of all to insert the scatter plot. Okay, once you highlight your data, you'll go to insert. Okay, after going to insert, you can either go direct to that is the scatter plot. Okay, or you can go to recommended, then go to all charts, then we have what? XY scatter. XY scatter plot. Okay. So once here now, of course, we are not interested with what? With the trend, because you can see the first graph is showing us the trend. Okay. Like how that is the rainfall amount has been trending. Okay. But now that is the other this other chart basically shows us the plot. Okay, the coordinates, how we are plotting our what? Our data points. Okay, so basically we are interested what? We are interested in that is in the second one. Okay, so we will choose the second one. Okay, good. Now you will find maybe when you will be doing that is your final that is exams. Okay, if you will be doing your final exams, that is for the certification exam, I saw such a plot. Okay, I saw such a plot. All right, and now the question was, okay, now the question was, From the picture above, mark the nearest correlation factor from maybe the choices, okay? And we had a negative, that is negative 0.6 something correlation. We also had a 0.145 correlation. We also had 0.891. Okay, now depending with this chart, what kind of correlation can you see, or what can you say about that is how these values are what are distributed? So those are some of the questions which you might come across. Something like this, and you are told maybe can you suggest the correlation, okay, the correlation we have here. Don't know, Donald, maybe you can mute. We are having some background, please. Hello, Donald. You can mute.
Okay.
Okay. Okay, thank you. Okay, good. So, um, so those are some of the questions maybe which you will be asked. Okay, so definitely you'll see that is the how the that is the plot is looking like. Okay, and also the distribution of your data points. Okay, you'll also check the distribution of what of your data points. Okay, so if they are far away from each other, we might have a very low correlation. Okay, if maybe also the data points were moving from this point to this point, from this point to this point, that would be a negative correlation. Okay, so in case you are given maybe also like you are asked such a question, and we have some points which are moving this, okay, in this direction, then you first of all you have to eliminate any negative correlation. Okay, why? Because you can see in case one variable is increasing, the other variable is increasing from the plot. Okay, you can see they are, that is, if we are to draw the line of best fit, we could draw a line which is a positive show, a line showing a positive relationship. But if the data points were moving from here to here, that would be negative correlation, meaning you would have removed all the what all the all the that is the negative, then that is all the positive answers. Okay, and then narrow back to the negative ones. Okay, so in this case, first of all we'll say that it is a positive that is correlation, and you can see the points are somehow aligned. Okay, if you can see they are not far away from each other. Okay, so basically this will be a correlation which is more than 0.5. This will be a correlation which is greater than 0.5, meaning this would be a strong correlation. Okay, but still we'll come to see that. Then maybe if you are doing so, of course we have properties of a good graph. Okay, in your case you can add axis. Okay, this is the y-axis showing now this is the umbrella cells. Maybe let me just edit that. So we have umbrella cells. Okay, and here now will be what we'll have rainfall. Sorry, rainfall rainfall amount. Okay, in millimeters. Okay, good. Then you can also do what? You can also edit and give your graph maybe the best um, title you'd like. Okay, good. So this is the very first part. The other part now is to what? To introduce a trend line. Okay, we are trying to find the line of best fit. Okay, so in this case we are going to add a trend line that is within what? Within that is within these data points. Okay, so with that we are going now to the plus sign here. Okay, where we have all the chart elements starting from the axis. Okay, that is if I want to remove basically axes are these one. Okay, like we have 0, 10, 20, 40, 30, 40. We also have 20, that 40, 60. Those are the axes. And if I remove them, you can see if I uncheck the axis, you can see now our graph has no axis at all. Okay. Then we have the axis titles. They are these ones. Then we have the chart title, which are these one. If at all we need the data model, that is the data points. Okay, like we want to see that is all the values. Okay, definitely now we'll introduce what? We'll introduce that is the data labels. Then we have the error bus. We have the grid line. Okay, the grid line here. In case maybe we want to remove those like the grid lines, they are these ones. Okay, you can see these ones. They are the grid that is the grid lines. Okay, if we want to remove them, we can remove them as well. Okay, then we have the legend. Okay, so like the legend is basically showing us the that is the different it's the key basically. Okay, and then we have the trade line. Under the trade line we have the linear trend line. We have the that is this is the linear trend line. So you can see on the graph we have now our line of best fit there. Okay, then we have exponential trend line. We also have that is linear forecast. In fact, we'll be using linear forecast. Also, we shall use linear forecast function to see how we can do what, how we can predict. That is our values. Okay. Then we have moving average. So basically, this is under where did we learn move things to do with moving average? That is under time series. Okay. Also, time series is also another that is a method of doing forecasts. Like by now, for that is for this depends with what the seasonality. Okay, it has high seasons. That is it is affected. Okay, when your data is affected with maybe seasonality, then you can use time series to do what? To do your forecast. Okay, and it will involve very many factors. Okay, so in our case, we will go to more, and all these are the things we've checked. Like for exponential, we've seen we can also present that is our data with exponential trend line. We have linear trend line. We have that is logarithmic. That is trend line. We have polynomial trend line, and we have the what? The power. Okay, that is the power trend line. Okay, and then we also have the moving average. Okay, so but our focus is on what? Linear, because we are assuming that we have a linear relationship between what? Between our two variables. Okay, so in this case we'll choose that is linear trend line, and here down here you are told maybe you can set your intercept if at all. Like for example, I don't want maybe this like this graph, you can see this linear or regression line, it will come to cut, that is the y-axis on the negative side from the what? From the look of things, you can see it will come to cut this, that is the y-axis on the what? On the negative side. All right, good. Then we have now, like if at all you don't want to cut it, that is on the negative side. Now if you want to set your intercept, you can do what? You can set an intercept. Okay, so if you want it to cut, that is to cut, that is a y-axis at maybe 10, okay, that is at the 10 value, okay, even though if we extrapolate still, I don't know if, yeah, just a minute, I extrapolate it and see if it will cut. Yes, if I extrapolate it, basically you can see I have already set the intercept. It will come to cut, that is the y-intercept on what? That is on 10. Y is equals 10. Okay, what if maybe I change it to cut it, that is on the origin? Okay, so you can see I have adjusted it. Okay, if you don't want to that is to take it to what? To take it to that is to 0. Okay, that is to negative side. Okay, so but for our case we just need it to that is to use, we want to use the intercept for the way it is. Okay, the way it is. So basically we won't choose that is the we won't set an intercept. Then you can now display the equation on the chart and also display the r squared. R squared, yesterday, remember we said it is the standard what? Sorry, it is the coefficient of determination. Okay, we said r squared is the coefficient of determination, and this tries to show the goodness of it, that is the goodness of it of our regression line. Okay, so I'm going to select the that is the equation, okay, on the chart, and I will also select that is the r squared. Okay, good. And you can see now these are the values which we are getting. Okay, so basically this is our, it's our model, that is y is equals to 0.4482 x minus 18.915. Basically it's what? Basically this is the our model, or that is our equation. Okay, which now we can use to do what? To do our predictions. Okay, we can now use this to do our predictions. Okay, then r squared basically means that our model, okay, or our that is 91%, 91% of our data is fitted along what? Along this regression line. Okay, it is fitted along this regression line. And then in case maybe you want to change that is the shape, that is how you are presenting your that is regression line, then it's also possible. If you want to make it to be that is a straight line, you can as well do that. Okay, like we have the dash type, you can come and just choose continuous. Okay, so if you choose the continuous, you can see that is how we are presenting it. Okay, you'll see how we are presenting our what? Our data, or our line. Okay, good. Now this is our equation, which now we can use to do what? To do our prediction. Okay, as I said yesterday, let's assume we are predicting for that is for 2018. Okay, 2018. And we are assuming we want the average of what? We want the average of these two, that is of these two years. Okay, we are assuming we will receive that is a rainfall. Okay, equal to average of the what? Of the last 2 years. Okay, that's just an assumption I'm making. Okay, so I need maybe to calculate the average of this data. Okay, average of this across what? Across all the months. It's just I'm just assuming this is the maybe the amount of rainfall we might we might have. Okay, we might have that is that is in the following year. Okay. Okay, good. Now we can use now, given these values, okay, given these values, we can now use our equation, okay, to do what? To predict the umbrella cells, given this amount of what? Rainfall. And how can we do that? Okay, we can do that using now this function. Okay, we can use it using this function. So we are assuming here now we have two values. We have that is the coefficient, let's say the slope or the coefficient of x value. Let me say this is what? Coefficient of that is coefficient of x variable, and we have what? We have our y intercept. Okay, so in this case we have a value of 0.4482, I guess so, 4482, which is positive value, and here we have a value of minus 18.915. Okay, so after this now we have the coefficients and we have our x. Okay, so now predicting our y values. Okay, it will be that is our constant coefficient of that is of x multiplied by our x, okay, variable, then we'll minus what? Or we'll plus minus 18. Okay, so in this case we are going to say this is equal to now our coefficient here, and because we are going to use that coefficient all through, okay, we can do what? We can now log that value. Okay, we can log that value, then multiply by our what? Our x variable or our independent variable. Okay, and then in our case, for us to that is to make it negative, we are going to say we are assuming we are plusing but a negative value. Okay, we are plusing but what? A negative value. So once we enter, now we will have what? We'll have our that is our predicted what? Umbrella cells. Okay, so and of course umbrellas cannot be presented as a decimal. Okay, so in this case we
Could you
have,
repeat that part again, kindly?
sorry.
Could you repeat that part again?
Okay,
Yeah.
so good. So we have that is now we want to use this.
Hi, Abraham. Is it possible you repeat where you got this, the y, the formula, our formula?
Which formula?
The y is equals to that,
This one.
yes, the coefficient 0.4, yeah.
So for that we came to that is it is when we were inserting the trend line. Okay, where we came to that is the plus sign, all the charts elements. We went to trend line. Okay, Then we went to what? More options. Okay. Then under more options, of course, we chose the linear. Okay. Trend line option. And then down here, you can see display the equation on the chart, and also display the R squared value on the chart. That's how we got it. Are we together up to that point? Are we together?
Yes, yes. Thank you.
Okay, most welcome. So now this is our equation which we are going to do what? To use to predict our what? Our x, that is our output or our y. We have a constant, that is the constant of attached, that is the coefficient of what? Coefficient of x variable, or the slope, okay, or the constant attached to x variable, okay. Then minus, because if we extrapolate, that is our regression line, it will come to cut, that is the y-axis, on the what? On the negative side, that is negative 18 point what? 95. So we are now going to use this part to predict what? Our y. Okay. So to do so, we'll come and say equal to, we have this, that is into brackets, we have the our coefficient of x, that is, which is which is this one, 0.4482, which is this one. I just brought this value here so that I may just reference the cell. Okay. And remember that if we will be dragging all these values, okay, we will have to lock this, or reference what? This point. Okay. So we are going to lock it. So already now this is our what? Our x, coefficient of x. Okay. Then you will multiply with what? You will multiply with, that is with um, our x value. Okay. So you can see it is 0.4482 times what? Times x. So we are multiplying with what? With our x value. Okay. Then plus, okay, our what? Our y-intercept. So we'll say plus our y-intercept, which our y-intercept is this value. Okay. And this value we are also referencing. So you will also have to do what? We will also have to log that value. Okay. And then you can enter. Once you enter, you'll get a value with decimals, and of course we don't have like 2 1/4, or two, that is 2 1/3 umbrellas. It occurs as what? As a whole number. Okay. So in that case, you can now just drag, that is your what? Your prediction downwards. Okay. And then you can see at this point we've gotten what? Our new projection. Okay. And if we want to see if that's true, we can try to see if we will, that is, we'll have the same trend as we had in the last what? In the last 2 years. Okay. Let me just assume, just a minute. I want to get this. I want it with the, okay, with the marks. So you can see this is for the what? This is for the last 2 years. That is for 2016 and 2017. Okay. What if we had for the what? For the 2018? Will we still have the same trend? Okay. Let's now try to add for the 2018 and see. Yes, you can see we are almost having the same what? The same trend. Even after what? Even after prediction. Okay. We are also having the same trend, meaning we'll be expecting the amount of rainfall on the same period, and whenever we have that is a high that is rainfall amount, so does the what? The umbrella cell. So we will expect more umbrella cells there. Okay. All right. That was just an illustration to show you that is our what? Our forecast or our prediction using linear what? Linear that is using the scatter plot. Okay, using the scatter plot. Question? Yes, Stella.
Thank you. I seem to be stuck on a page whereby there's only the data set. I'm not able to see the illustrations. I don't know whether it is me alone or
Sorry, you are.
I, I'm not able to see the illustrations, the ones you are doing. I'm just stuck to a stagnant page whereby there's a data set for 2016, 2017, and then we are using chart and trend line. I'm not seeing all these illustrations you're explaining.
Maybe is it happening to the others, or maybe it's Stella's network?
That's what I want to find out. It seems.
Maybe let me ask the others. George, Celine, Elizabeth, Donald, is my screen that is clear? And also,
For
yes.
mine is clear.
So maybe Stella, you will have to check your internet.
Okay.
Yeah, for me, it's not yet clear, sir.
Sorry.
For me, it's not clear. It's showing a number of screens.
So, okay, that is, yeah, I know it's because I've come to this area, but right now,
And now I can see clearly.
yes, yes. So, yeah, it is maybe Stella, you can check your network.
Okay, let me try to log off and log in again.
Okay, all right, good.
Thank you.
Let's continue. Any question? Any question up to that point? Yes, Elizabeth.
So it's that place where you are trying to, what is it called? Trying to set your y-intercept. So my question is that allowed?
Mm-hmm.
Because for me, it seems like if you try to set your y-intercept, you sort of like change your
Regression line.
model, yeah, and it's also very, very, very not good to also because it is sort of like also in terms of your prediction,
Yeah, it will
it's
also
sort of affect it.
affect.
Yes,
Yes, yes.
yeah.
So basically on the set, that is where we set the the y-intercept. Okay, it's like, for example, if you are trying to, if you have an hypothesis testing. Okay, so you are trying to see if I set that is my uh, my y-intercept to a particular value. Okay, definitely it will change everything. Okay, it will even change that is it's like you are forcing your model, okay, to assume a certain what, like to assume some specific, or to fit some specific what, some specific values. Okay, so basically it's not always advisable that is to change or to set that is the y-intercept for yourself. Let the what, let the that is the data, okay, or let the Excel do what, do perform that for you. Because if you try that using this method, what if maybe you are using the other methods, like the using the regression analysis tool, where you don't have to, where you don't have the option to set what, to set that is the y your intercept. So basically here, what I can say, basically you use the, which is rarely used, that is to set your y-intercept if maybe you need to do some what hypothesis testing. Okay, like when I try this intercept, how will our model behave? How will it perform such things? Okay, but it's not always recommended. Right? Yes. Then I can see Titus.
Hello.
Yes.
Yeah, I think I lost you some when you were trying to extract the model.
Hmm.
So I don't know how you came up with the y is equals 0 point something minus the 18.
But I repeated that how to we got this. I
Uh,
even repeated once again, unless maybe
I was following,
uh-huh.
but how you came up with the y minus y is equals 0.4482x minus 18.915.
Hmm.
That's where I did not get you right.
So for this, the model generates itself. Like the Excel will generate itself. Okay, it's not has to calculate. Like for example, let me just redo it again. Okay, when you come to trade line, okay, then more options. Okay, then there is an option to set maybe the equation of the chart, which will be automatically that is generated, okay, from what, from this line. Okay, so if I display the equation of the chart, you can see it has come here. Okay, okay, so if I also want to display just a minute, I've only displayed there. Yeah, I can just work with this. Okay, so you can see it has displayed it, it has done the back end calculations. Okay, that is the sum of squares, that is a mathematical method to come up what, to come up with the constant and the y intercept. Okay, all right, Titus. Hello.
Yes, I'm okay. I'm okay now.
Okay, good. Okay, another question. Daniel, yes.
Um, okay, I might have you lost me on how you got those predictor values for rainfall just for 2018. But when I typed those, that is, yeah, 84.5 and
So
95
for
using the function type.
yes, so for this one, I took the average of the last 2 years. Okay.
Ah, okay.
Yes, the average of the last 2 years.
I was wondering how you generated the random numbers. Okay, but now I'm okay.
Yeah, yeah. Okay, good. Maybe just to give you a bonus, if you don't want to follow all these calculations, okay, if you don't want to follow all these calculations, we have some inbuilt functions, okay, in Excel, which can give you what? The same values as here, okay, which can give you the same values as these ones. Okay, so now with that we are going to use what we call that is linear. We have forecast linear. Okay, so we are going to use forecast linear. Okay, so that is one function, and we will also use a trend function. Okay, we'll also use a trend function to do what, to of course return or predict what, predict the number of umbrella cells. Okay, if you don't want now to use maybe the graph, plot the graph, come up with this equation, compute this, no, we also have that is easier ways to do that. More so if you don't have time and you have to perform what, you have to do your projections. Okay, so with that we have that is the forecast linear, okay, or the linear forecast. And under the linear forecast, you can see you will be needed to insert the value of x which are our new that is predictor variables, okay. Then we have non-y's, they are our what, our historical, okay, they are our historical values of y, okay, all the dependent variables, the values, okay. Why? Because that's why we are saying non-y y's, like they should be existing, okay, or you should have them available, or you should have that data, okay. So we are going to say that is forecast linear. Then we want to for that is to use our that is our predictor variable, or our independent variable. Then we want y or non-y's. So for non-y's, they will be, that is the data for the last what, for the last 2 years, okay. Then comma, we also need non-axis, we also need non-axis. So for that case, we are also going to choose what, then that is then historical data for the axis, okay. And for us now, because we will drag this downward, okay, we will have to do what, we will have to lock, that is our historical range of data, okay. So in this case here, I will lock this, I will lock this, I will lock this, I will lock this, okay. But the x is changing, the x is changing, so I don't need to do what, to lock it, okay. So after that, now you can do what, I can just make it to be a whole value, okay. Then once I drag, okay, once I drag, you can see I'm getting what, I'm getting the same values as the one we used what, we used the first method, okay. So of course we have now the forecast linear function, okay. We also have the trade, which is more likely more of the same as the forecast, okay. And you can see the trend tries to return numbers in a linear trade, matching known data points using the least square methods, okay. So for that, now we are going to select what we will need the non-y's, we'll need the non-axis, and then we'll need the what, the new axis, okay. So in this case, we are going to start with the y, that is the non-y's. So these will be our non-y's, okay, comma. Then we'll need what, our non-axis, okay. So as well, we'll do our non-axis, okay, and then comma, we'll choose what, our new axis, okay. That is our new axis. Now they are the for the that is the months we are trying, the values for the months we are trying to predict the umbrella cells, okay. Of course, for the same, you will keep it as a whole number, and then you can drag it down, and you can see we are having the same what, the same values using that this method, also use this method, and also using this method. So meaning our prediction definitely should be what, should be correct. Why? Because we are getting the same what, the same values for different calculating methods. Any question up to that point? If we are all good, maybe thumbs up, by show of thumbs up. Okay, we have one. Brian. Yes, Joy.
Kindly share the formula for trend again.
So So okay, so for trend, I've said for trend we are saying it's equal to trend. Okay, then you can see the formula itself shows you what you need. You can see we need the non-y's, the non-x's, and the new x value. So if you choose the non-y's, which are the historical, that is values for y, okay, and non-x's, they are historical values for x values, okay, then you will do what? You will get that is these values.
What's the constant value?
For that, we don't have a constant value here, no assumption,
Oh,
yeah, to keep anything constant. You will just enter your, that is your formula at that point.
okay, thank you.
All right. We are all good. I want to see thumbs up if we are together. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 8. I can see only 8 respondents out of 20. Does it mean the others we are not together? Okay, Jennifer, we are okay. Daniel, are we not okay? Titus, are we not okay? Him, are we not okay?
So I'm okay. I would
Okay.
like to ask a question.
Yes.
Looking at the data set that you gave us or that was shared on the screen, let's have, okay, like the way it was, the output variable to be the umbrella price, I think, and also the independent variable, and it was considered to be the rain. Um, I would like to ask, there could be probabilities that maybe let's have the rain, but let's consider another variable whereby we may have the summer or the winter. So this rain season may also have an impact to the umbrella that are sold. In that case, how can we deal with such a kind of variable? Because between the rain and the season, yeah, one of those may have a great impact to the umbrella sword.
But of course, if when we are having low rainfalls, what does it mean at that point?
I mean that let's take that the mass. If you look at the mass column,
Sorry, if I
if
the
you, if
month column.
yeah, mass column.
Uh-huh.
So like, yeah, winter or summer, this season may have a great impact to the umbrella also sold.
Yes, of course they have impact. That's why you can see during
Oh,
that period, that is the
okay.
umbrella cells, they are going down. Okay.
Okay. How could we include that in our regression function or
So
mathematical function?
so for this you can see the nature of the that is of the data set. You can see it's a string. Okay. When we are dealing with the regression, we are dealing with only data values. Okay. Nowhere we will use that is February or maybe to to show that. So with that, maybe we can only show the trend. Okay, we can only show the trend, but we cannot calculate like the impact where that is on that is the impact on that is during April. Okay, May, March or let's say, let me check the areas where we have low rainfall. That is January, Feb, and March. So you can see, like from January, Feb, and March here, okay, the rainfall amount is very low because it is a season. We know we usually receive less, that is rainfall amount. Okay, but when you come now to April, to July, okay, the rainfall amount, that is the rainfall amount starts to what? To increase until July, and then starts to decline from what? From August. Okay, the same trend which we are having here, it is the same trend which we are having what? On the rainfall amount. Okay, so for this case, we can only maybe predict that, or we can only conclude that that is during the maybe the summer period, we usually receive what? Okay, we usually receive less rainfall amount, or no rainfall. So definitely the what? The umbrella cells will be what? Will be also low. But we cannot like compute like a value, okay, or an impact. We cannot calculate an impact that is using now the months, but we can explain what is happening, unless maybe you have maybe a way, aim, maybe you've ever came across, and maybe a way you can measure that impact.
Well, it requires advanced tools, but with MS Excel, we can only see the trend.
Yes.
What I wish to see if there could be a way of dealing with that in
But
using the Microsoft Excel.
for that, I'm not really sure.
Ah, okay.
Yes.
Thank you.
Okay. Good. Seems we are all good. So we are done with the first method using, that is chart and trend line. Okay. So the second method, let me just recreate another, that is let me just recreate another sheet. Okay, so the second method, that is the second method, is using now the analysis tool pack. Okay, analysis tool pack. So for this, of course, now we are going to use our headings function, that is the data analysis. So you will go to data, then go to data analysis. Okay, check on the data analysis. Then under data analysis, I'm just going to, since I can see the class is almost, that is our time is almost ending, I'll just output, that is the analysis, and then now from tomorrow we'll do what? We'll discuss what that analysis means. Okay, so from tomorrow we'll discuss what that analysis is. So in this case, we'll go to data analysis. Okay, then from the data analysis we need what? Regression. So you'll come to the regression part, select regression, then click OK. Once you click OK, it will request you to input. Okay, it will request you to input your Y range and your X range. So for the Y range, you will come here and then you will highlight what? Your Y range. Okay, if it is X range, okay, you will come here where we have X range. Okay, then out, that is input your X range. okay? And if, okay, if that is you've selected even the titles, okay, you'll have to select the labels so that when it is calculating, okay, it excludes the first row, okay, the first row in your calculations, okay. Good. Now, when it comes now to confidence level, like we are trying to assume, okay, our model performance it's performing maybe 95% or within a specific range. Okay, we usually have a confidence level of 90%, another one for 95%, another one for what? For 99%. So for 99%, I said it is for medical experiments more so when you are doing analysis for medical, for any data collected for that is medical observations. And then for 90 and 95%, we usually use for that is for in the normal research research work. Okay, so we'll choose our confidence level to be 95% because this is a normal research. Then I want what? I want our output range, okay, to be in the same workbook, okay. I want our output range to be in the same what? Workbook, okay. So in this case, I'm going to choose output range. Then here, select that is the cell where I want to output the range, okay. Then after that, I want now, I also want what? I also want now to get residuals, okay? I want to get residuals, remember, that is the error term. And also I might need what? I might need normal probability plots, okay? That is for our error term. So in that case, I'm going to click OK. Okay, so once I click OK, you can see I'm getting what? I'm getting some that is some outputs here. Okay, I'm getting that is a lot of outputs here. Okay, so the first output, it is what? The summary output. Under the summary output, we'll discuss about multiple R, which is our correlation. We'll talk about our R squared, which is our coefficient of determination, showing that is the percentage of our data which has been used to that is to create the regression line. We'll have adjusted R squared, majorly used when it comes to that is multiple linear that is multiple
Excuse me.
linear regression. And then we have standard error, and we have now the
Sorry,
observations.
I
Yes,
have a question.
yes.
Now, in my Excel,
Hmm.
I cannot find that function of data analysis.
So does it mean you did not include it in our first classes? Because we added it. We did not have it, but we added it. Maybe you missed that class.
It is under data.
Sorry? Yes, it is under data. But if you've never worked with it, you won't see it. So you will have to add it. Maybe just for your maybe case, and in case maybe we have someone else who missed that. To add it, go to File, okay? Then on File, go to Options. Once you go to Options, you'll see and that is a pop-up. That is a pop-up window. Then go to Add Ins. Along this, that is bar, you will see Add Ins. Okay, Add Ins. Then click here. You will see Go here. Okay, you will see Go here. So click that Go. Then check the analysis toolpath. Okay, check where you see the analysis toolpath, check that is the box, and then do what? Click OK. Once you click OK, now come to data and you'll see data analysis. Together up to that, up to there, Joseph? Joseph, are we together up to that point?
Ye-
Have you managed to add it?
yes. Yes, we are together. Yes.
Okay, good. Yeah, so tomorrow now we will explain each of these outputs
We are
that
together
okay,
to
okay, thank you. So tomorrow we'll
up that point.
yeah, good. So tomorrow we'll now discuss about regression statistics. Okay. We'll also discuss about the ANOVA, that is the analysis of variance. We'll talk about degrees of freedom. We have sum of squares. We have mean square. We have F statistic and significant what? Significant F. Okay. Then after that, we will also talk about the coefficients here. Okay, so you can see we are getting we are getting the same coefficients. Okay, you can see we are getting the same coefficients, the ones in comparison to the ones we got in our first what? In our first example. Okay, so these are our coefficients, and then of course we have what? We have that is our residuals. Okay, that is prediction, and then our residuals. Okay, all right. Yes, Titus, do you have a question, Titus? Okay, good.
Sorry, it is a mistake, eh?
Okay, no problem. Okay, good. So I guess now we are all good up to that point. So tomorrow we'll have we'll finish this part, and then also have some Q and A session for what? Q and A session for that is for that data, okay? Or for that um, that is for that session, okay? All right. Otherwise, thank you and have